Hello students, today we are starting a new chapter. Today we are doing chapter number 6, sound, and we are doing part 1, and we will be discussing the following topics. So to introduce sound, as you know, in physics we encounter different forms of energy, and sound is one of them. So sound is actually a form of energy, and this energy causes a sensation of hearing. So as sound travels to your ear, you are able to hear the sounds. So sound is a form of energy, and it causes a sensation of hearing. Now, what are the sources of sound? See, any vibrating body is a source of sound. For example, if you on a table, if you place a wooden scale and you put a weight on one side of the wooden scale and hold it down, and on the free end of the wooden scale you push it down and you let it go, you will find that this scale will move up and down and it will vibrate, and this vibration, as you will observe, will cause the production of sound. So as an example, if on a table you take a long wooden scale and at one end of it on the table you place a weight so it doesn't move, and the free end you push it down so that it starts moving up and down, and this up and down motion is called vibration, and this vibration causes the production of sound. Now let's discuss next about the musical instruments. So sound can be used to produce music, and musical instruments can be categorized into 4 types. So the first one, let's say, is the wind instrument. And something that you're very familiar with, that is your one wind instrument is called the flute. I'm sure you must have seen it. It is basically a pipe or a wooden pipe, and there's one blowhole at one end, and there are 5 or 6 holes next to those, and you have to cover those holes and blow at the blowhole to produce a sound, and with this series of sound you can produce music. So this is a flute. And another instrument I will name here is a trumpet. Trumpet is also a wind instrument which produces music with the help of wind. The next category of musical instruments is called the stringed instrument, stringed. I'm sure the most familiar stringed instrument that you see being played is probably the guitar. A guitar is an instrument that looks like this. Okay, it has got a fretboard, and there are a series of strings that is placed across the board, and as you strum the strings the sound is produced. So this is a guitar. And another instrument that I'll name as a stringed instrument, and that is called, let's say, violin, violin. This is a string instrument because it is the string that is stretched across the body of that instrument which causes the production of sound. Next category of instrument is called the percussion. Percussion instrument. So these are instruments in which you have to strike to basically produce the rhythm or the sound, and the most familiar instrument of this category is the drum, and one Indian instrument I'll name is the tabla. So these are 2 examples of the percussion instrument which you have to strike to produce a sound or a rhythm. The next category of instrument is the reed instrument. A reed instrument is basically a wind instrument itself, in which there is a vibrating reed. So let's say this is the portion of the instrument where you have to blow to pass the wind through it, and inside this there's a small vibrating instrument part which after it vibrates produces a sound, and which is amplified at the other end, and it is able to produce music. So this small item, which is called the reed, and since it vibrates and produces the sound, so it is called a reed instrument. And the example that I can give here is the mouth organ, and the next instrument is the bagpipe. So these are two instruments that I am giving as an example, which are reed instruments. So with all the instruments which produces sound, we can play music with all of these. Next, let us discuss about the human voice. As I am speaking here, you can hear me. I am producing a sound, and I am modulating those sound to pronounce the words that I am speaking here, so you can understand me. So how this happens? See, the sound box is placed as a pathway on a throat, and that is called larynx, L-A-R-Y-N-X, larynx, and it is also called the voice box. It is located at the throat and it produces a sound. It basically consists of a tube in which there are stretched membranes through which sound passes, and that's air is coming basically from the lungs, and it causes this these are called the vocal cords, and they vibrate and they produce the basic sound. And this basic sound, as it comes out from the voice box, is modulated further by a jaw, a tongue, a teeth, and a lips, and basically we mold the sound to pronounce the words that we want to speak, so that you can understand. So once again, human voice is basically produced by the larynx, which is called the voice box, and it is placed in the pathway of our throat through which air passes, and there are two stretched membranes, and there's a slit in between through which the air passes and causes this vocal cords to vibrate and produce the basic sound. This basic sound is further modulated by the jaw, tongue, teeth, and lips to pronounce the words that we're speaking, so that we can communicate and we can understand. So this was about the voice box, human voice. Now let us discuss about how sound travels. Now, as I'm speaking, you are able to hear me because sound is traveling from me to you. So sound is being produced at my throat, but it will be of no use unless it reaches you. You may have the hearing capability, but if it doesn't reach you, you'll not be able to hear me. So sound has to travel from the source of the sound to the recipient of the sound. So how does sound travel? Sound travels in the form of waves. Sound travels as waves. A wave is basically a disturbance in the medium. Okay. So what is a wave? Wave is W-A-V-E. Wave is basically a disturbance. Disturbance, it is produced in the medium. And what does it do? This disturbance basically carries the energy from from the source of the sound to where it's supposed to reach, and this happens without the transfer of matter. So essentially, if you have stood in front of a water body, let's say for example a pond or a lake, and you have thrown a piece of stone in that lake, you will find that it creates a series of waves which appears to move. But if you find any object that is floating on that water, that object does not move along with the wave, although the wave appears to move. You will find that object that is floating on the water basically moves up and down. So that up and down motion is the disturbance in the medium, okay, and that disturbance is basically propagated throughout the water from the point where you threw the from the point where the stone dropped in the liquid and travels further out from that point onwards. So once again, how sound travels? Sound travels in the form of waves. What is a wave? A wave is basically a disturbance produced in a medium, and that disturbance basically carries the energy in the medium, and it does not transfer the matter. It just causes the motion of the particles in that medium from from its mean position, and it basically transfers the energy across. So as I was saying earlier, let's say you have a surface of water, which is right now is still, and if you drop a stone at one point, this will cause this section of the water to be depressed, and since water is elastic, this portion of the water will try to come up, but as it does so, it transfers that the energy to the next particle, and this basically travels as a wave. So wave appears to travel, but in this case the particle just simply move up and down in its own position, okay, till it comes to its rest state. So the wave energy travels forward, but the particles don't move from its position along with the wave, but it just moves about in mean position at its wherever it was in the initial place. So this is an example of how sound energy travels through a medium. Now, depending on the way the particles of the medium vibrates, there are two types of sound waves. So first of all, there are two types, and these two types basically depends on the direction of the vibration of the particles of the medium. So once again, there are two types of sound waves, and it depends on the direction of the vibration of the particle medium. So I will list them out in the next board. So the first type of sound wave is called the transverse wave. Now in this type of wave, if this, let's say for example, let's say these circles basically represent the particles of the medium, you will find that in this type of transverse wave, the particles basically move up and down, or basically perpendicular, and this up and down motion basically carries across from one particle to the next. Okay, and if this is the direction of the wave, you will find that the direction in which the particles are vibrating and the direction in which the wave is traveling, they are perpendicular to each other, which means that it makes an angle of 90 degrees. So in the transverse wave, the particle about its mean position moves up and down, and in such a way that it is perpendicular to the direction of the wave. So sound energy travels this way, whereas the particle moves up and down. So one of this is the definition of a transverse wave. And these wave basically creates a crest, means as the particle goes to its highest position from the mean position here, and it follows a trough in which the particles go below the mean position and follows that. So this is this portion where the rise is the maximum. This is called the crest of the wave, and the portion in which the particles are at the lowest position below the mean position, that is called the trough of the wave. So this is the representation of the transverse wave. Next type of wave is called the longitudinal wave, Longitudinal wave. So let's say these represents the particles of medium. In this case, the particle of the medium travels or moves in the same direction as the direction of the wave. So let's say this is the source of sound, and it causes the first particle to get pushed and it causes it to vibrate. This particle causes the next particle to vibrate, and this particle causes the next particle to vibrate. So it basically transfer the energy from one particle to another, but in this case the particle is vibrating in the same direction as the direction of the wave. So if this is the wave, the direction of the wave, this is also the direction in which the particles are vibrating, and you can see that since the direction are same, this type of wave is called the longitudinal wave. Now in a longitudinal wave, let's say if these particles are spaced equally apart, let's say the first particle gets pushed by the sound energy. So it causes this particle, let's say I'll draw in the second position, it causes the particle to come close to each other. As you can see here, this particle got pushed and this particle was there in the next position, and this particle reached here, and you can see that these particles are now closer to each other. When the particles are closer to each other, so this is called a compression. This part of the wave is called the compression, and as the particle moves away and tries to come back to its mean position and it overshoots, you can see that now the distance between the particles is more as compared to the distance that is normally between the two particles. You can see this more here. This part of the wave is called the rarefaction, RAREFACTION. So in a longitudinal wave, the wave moves in the forms of compressions and rarefactions. So the some portion of the waves, the particles are close together, so those are called compressions, and some places the particles are far apart, those are called the rarefactions. So this is essentially how sound travels through a medium in the form of longitudinal waves. So today now we come to the last part, that is sound requires a medium to travel. So first of all, sound can travel through any medium. So it can travel through any medium, which means it can travel through solid, it can travel through liquid, and it can travel through gases. Right now, as I am speaking to you, sound is traveling through gases to reach to you. And it cannot travel through vacuum. Vacuum basically means an absence of either solid, liquid or gases. That means none of the particles or none of the molecules are present in that space. So sound cannot travel through that, because we already mentioned before that sound requires a medium, and it can be solid, liquid and gases is required for the sound to travel. Now to prove that sound is required, that is medium is required for sound to travel, we have a very simple experiment which can be done. You can find this experiment being conducted on YouTube. I will also be posting a link later. So it basically consists of a bell jar in which the bottom is placed on a plate, in which there is a proper seal between the plate and the bottom of the bell, and in the upper portion there is a cork through which we pass two wires and we suspend a gong bell. So this gong bell basically has a hammer and a gong, in which when the hammer strikes the gong here, it produces a sound. And the bottom portion of this plate is connected to a vacuum pump. So in the beginning of the experiment, this bell is connected to a battery and it is switched on, and let's say a switch, and the switch is put on, you will find that this striker is striking the gong. It produces sound and you can hear it because at that time air is present, and this causes the sound to travel through air, through the glass, and it can reach your ear and you can hear the sound. Now, what we do next is we allow this bell to ring and we will be hearing the sound. So, at that time we will switch on the vacuum pump and we will remove the air that is inside the bell jar. So, as we remove the air and air becomes less and less and less, it creates basically a vacuum condition. You will find that although the gong is still striking the bell, you will not be able to hear any sound. So, the only explanation here is because you have removed the air, which is the medium of transfer of sound, through the vacuum pump, and now there is a vacuum that exists here. Sound cannot travel from the bell to your ear. Now, what we do next is we stop the vacuum pump, the bell is continuing to ring, and slowly we allow the air to enter inside again, okay, and you will find that slowly we will be able to hear the sound, which becomes louder and louder till it becomes to the maximum loudness when this bell jar gets completely filled with air again. So, this very simple experiment proves that a material is required for the transfer of sound. Thank you, everyone.